here we're going to look in section 4.1 at exercise number 1, which has y equals c1 e to the x plus c2 e to the x, e to the minus x, I should say, and where the solution is defined from minus infinity to infinity, and it is the solution, or is a member of, or is a family of solutions for the differential equations y double prime minus y equals 0. And we're given now some initial conditions: y of 0 equals 0, y prime of 0 equals 1. And in the directions, we're asked to find a member of this family. And by that, what we mean is basically find what C1 and C2 would need to be in order to satisfy these initial conditions. Okay, to do that, I see that I'm going to need y prime, so that's the first thing I will do. I will go ahead and find what y prime is, and y prime is c1 e to the x minus c2 e to the minus x. Next, I will look at my initial conditions. So y of 0, using what y is right here, is c1 e to the 0 plus c2 e to the minus 0, but it's the same as 0. And so this is c1 plus c2. But according to the initial condition, again, right here, I know that this is supposed to be set equal to 0. Okay, and then again, I now look at y prime of 0, and using y prime, which I just found, I see that that's c1 e to the 0 minus c2 e to the 0, which again, this is just c1 minus c2, since e to the 0 is just 1. And according to the initial condition, now for y prime, this is supposed to be set to 1. Okay, so what I see now is that I have two equations and two unknowns, and so I'll use those to find C1 and C2. So C1 plus C2 equals 0. C1 minus C2 equals 1. One thing I can do is just add these two equations to give me 2 C1 is equal to 1, and that just gives me C1 is equal to 1/2. And that is by adding the two equations. We obtain that. Now, if I know C1, then it's easy to get C2, because from equation 1, that would tell me that 1/2 plus C2 equals 0, giving me that C2 must be equal to minus 1/2. And so now I have my two constants, and I can write the member that solves my initial, my differential equation with the given initial values, and that would be 1/2 e to the x minus 1/2 e to the minus x. And this is what the solution I am needing to find.